All right, so I have a couple of slides. I know I'm a letdown given that Armand had to come out with the great whiteboarding. So, but we'll get into a good demo pretty quickly afterwards. I'm going to fly through these slides just to kind of set up what you're going to see in the actual demo. We're going to step through a lot of the stuff Armand talked about, a lot of the things around Nomad and using Nomad to deploy workloads that Consul understands, and then be able to actually connect multiple environments together and actually use a mesh in a practical way. So many of you know me, so I'm going to breeze through this. My name's Cody. I do technical marketing for Consul, and I have a former history with many of you, so I'm really excited to be here. Thanks for giving me the time to come in and talk about Consul a little bit. I wanted to start out by framing, like Cody's perspective on what Consul is. And like, there's a lot of things, and Armand touched on a lot of the capabilities that Consul has and kind of the overall ethos of Consul. But when I think about Consul is a tool for how we connect applications together. Right, and Consul is a tool for making those connections across clouds and runtimes simpler and easier to operationalize. And service mesh gets a bit of a shtick in the community, but I like to think of the things that we do in service mesh in the way of outcomes and things that you are trying to solve for, as opposed to just adopting the new kind of cloud native hype cycle. In a typical environment, everything you're doing is really centric around connecting app A to app B or app B to app C, like two different environments together in some way. And you start to run into the problems when you get into the place of scaling those applications up, or when you start to want to branch those applications into larger stories, microservices, building across data centers, across clouds, so on and so forth. So how do we handle application lifecycle in an intelligent way? How do we take these things that we're building and make an easy way for us to replace them and grow them and change them as time goes on? And the problem gets more complicated when we look at how we do this across multiple environments. So how do we do this across clouds when the majority of your environment is in a vSphere-based data center, and then you want to branch into Azure and into AWS, or span across them with the same application? It gets even more complicated when you start to look at the runtimes. Keith brought up some good points around Kubernetes, and we talked about Nomad. Like, these are all very viable ways to deliver applications with their own benefits and their own perils, but they do require different operating models in order to execute on them and actually do something useful with them. So how do we have an environment that lets us stretch this between those different runtime platforms as well, while still taking security into mind? It's obviously been a hot point of the conversation, so I don't think we need to dig into that one too much. It took me a while, to figure out, before coming to HashiCorp, what service mesh was, and I have a good story around it that I'll save for the lobby afterwards. But I like to think that service mesh is about treating applications first in the network, and it's a set of outcomes that you want. Things like that zero trust networking, the automatic MTLS encryption, ways to very dynamically deliver progressive delivery of applications. How do we lifecycle? How do we split and do failover between environments? These are all outcomes, and they're not married directly to cloud native applications. They're not tied to the world of Kubernetes. They're obviously something that's front of mind in Kubernetes, but as Armand mentioned, we have legacy environments, we have traditional environments, we even have environments that we've built new that aren't old yet. We just are adopting these more microservice approaches, and how do we bring that into the fold? And I think that the outcomes of service mesh have a very big part to play in that. And when we talk about Consul, there's a couple things that we really focus on that we're going to show in the demo. We talk a lot about multi-runtime support. How do we treat things that are VMs equal to things that are Kubernetes and equal to things that are in Nomad as well? How do we create consistency between inconsistent things? Furthermore, how do we actually connect things between clouds, right? So if you have multiple data centers, if you have multiple isolated environments within an on-premises data center, if you're growing into public cloud and you want to have a consistent way of applying network control, network policy across all of those, that is a part and parcel service mesh problem. And we approach these problems that are networking and application networking focused with the methodology of workflows over technologies, which is why we focus on the problems people have in this space and solving those in really elegant and operationally safe ways. I'm gonna skip over this. Armand covered our use cases. We also dove into that quite a bit. So this is kind of a rough idea of what Consul looks like inside of an enterprise operating in this central control plane manner, where you have these different environments that are connecting into Consul, and Consul is really managing how applications communicate between these environments. And we're actually going to jump into the demo right about now and tackle this through starting off with Nomad and applying some jobs into Nomad, showing how that mesh functions. And then bring a set of Kubernetes clusters from all of the major cloud providers into that same model and show how we can route traffic between those environments. And then once I'm done, I believe Nicole's going to show us how you guys get started actually doing this on your own with a couple of our tools as well. Let's go ahead and jump into the demo. I know there were some questions about Nomad. I just wanted to do, a good magician always shows that there's nothing up my sleeve. This is a blank Nomad environment. You can see that I have 3 servers in place. And then 3 clients in place. The client nodes are where workloads land. I'm using Nomad just because it's really easy for me to schedule traditional workloads onto virtual machines, as opposed to SSHing into every box and deploying my application. I can very easily schedule a Nomad job and have Nomad deliver this. And there's the integration between Nomad and Consul is truly like a magical thing. Many of you know that I'm very much a nerd who loves digging into technology. And when I look at what we do between Consul and Nomad, it solves so many problems that exist within like the traditional application delivery, like life cycle and application delivery problems that exist today. So I've got no jobs in place, and I have my Consul environment here. By default, I've set up kind of some baseline configurations inside of my Consul environment. This is running inside of my data center at my home. So this is my vSphere lab sitting in the garage. This is a 3-node Consul cluster. I've got a mesh gateway set up, and what the mesh gateway is going to allow me to do is bring multiple other environments into Consul by something we call federation. So federation is how we take multiple Consul environments and stitch them together into one consistent environment. So this 3-node virtual machine-based Consul environment is going to act as the backbone for an EKS cluster, a GKE cluster, an AKS cluster, as well as a vSphere-based Kubernetes cluster, as well as the Nomad workloads that are going to be deployed inside of it. We pop over the intentions. I've gone ahead and enabled intentions here. I'm going to actually disable it, or I'm going to set up as a default deny so that all traffic is restricted by default. So we'll have some failures when we start to deploy our workloads and start to try to consume them. We have all of our nodes listed here. There's no additional nodes in the environment yet. We're going to go ahead and flip over into VS Code. And we're going to start off talking a little bit about service discovery. We consider service discovery as the foundation of Consul. Everything that you do in Consul is based on discovering these workloads and bringing these workloads into kind of that catalog so you can see the health, see how they're performing, see how many nodes you have, get DNS resolution around them. Something interesting I want to share is that within my environment, I've set up my DNS to forward into Consul. So anything that's inside the Consul domain space will resolve using Consul. And if I go into a terminal window and I do like an NS lookup against Consul, you can see this is actually being returned directly from that cluster. So when we talk about service discovery and that basic east-west traffic pattern, this is what we're talking about. When I register this first service with Nomad, which we'll go ahead and just do to get rolling, I'm doing this with Terraform, so I've got a Nomad job here. The Nomad job spec is very easy to understand. We have a job running in my virtual machine data center. There's a group of nodes. I'm going to deploy 3 of them. There's a task to run this actual server. I'm running it as a Docker image, so it's pulling down my app as just a regular old Docker image. I'm setting up my basic network configuration, and the big important part is this service stanza, where I'm configuring my basic front-end service. So if I go in here and I do a Terraform apply, and I very quickly switch back into Consul, this service is coming up now, and it's up and running. It's available inside. If I click on this, we can see the 3 nodes. And if I go in to that terminal window I was in before and do a NS lookup against basic fe.service.consul, I think I spelled it that way. Let's double check. Oh, I spelled it out the whole way. We can see all of those respond immediately. So if I curl that, if I do just curl, let's cheat sheet like this. It's going to take it, or take, oh, sorry, because those are dynamic ports in Docker, I have to grab one of the actual port addresses. We can hit this a different way and show it in a moment here. This is actually running inside of the environment now. If I go in and I grab one of these IPs, I can actually connect directly to that and see that server come online. And this is interesting, and it kind of highlights a problem that I was setting up via the demo. This is running, but because this is running against a Docker host, the port that's mapped to Docker is dynamic, right? Like I don't have a way to, I can statically assign that, but that becomes problematic. What if I'm running multiple web front ends on these Nomad hosts? I can't have 4 things all using port 80. That's going to cause problems. So in this case, I'm able to register and do health checks against this. And you might have seen those health checks inside of here. This basic HTTP health check, making sure that we can resolve HTTP service. If that health check starts to fail, Consul will remove that out of the resolution list, and it won't resolve back via DNS. But if I want to hit this, I'm going to need to specifically use these ports. This is when we start to get into like the network middleware automation or network infrastructure automation story, and how we start to automate like load balancers. And this directly translates into the story of automating and updating firewall rules as a downstream. So I go ahead and grab this, hit this, it should go ahead and resolve. So hi Cloud Field Day. Just a little basic app, just showing that we're hitting those servers. But again, just to harp on the point, if I wanted to hit this in a consistently easy way, I can't just hit the basic front end .service.console because I don't know those ports by heart. So we're going to move into the next part of the demo where I actually bring up an Nginx server and take this to the next level. I'll pause for a moment before I cruise forward if anybody had any questions around what I've done so far here. It gets a lot more interesting as we move into what I call the network infrastructure automation side of the story. So this job is a lot more complex. If we look at our Terraform manifest, we can see I'm hitting my console environment, and I've actually got 4 sets of resources that I'm deploying. Now, it's important to note that I'm doing this in a little bit of a backwards way. In Nomad, you could typically, if you had a group of services together, you would put them all in the same job file, and Nomad would schedule them all. I broke this up into parts because I wanted to actually show the multiple aspects of resolution. I just realized that I didn't show the app actually running inside of Nomad. I can dive into Nomad here, and I can see some additional detail about this job actually running. I can get logs from within the container, right? So I can see the health check succeeding. So Nomad's giving me a bunch of information around this scheduled, and Nomad is handling how this schedules out into the environment. So I'll go ahead and do a Terraform apply against this workload. And we can see a whole lot more jobs are now coming up. I've brought up a front end service, an API, a database, as well as an Nginx server. And if I go back into console now, we'll see we're getting a lot more. And there's a few things now that show this connected with proxy. Nomad has the ability to interact directly with console's service mesh functionality. So when we deploy workloads using Nomad, we can automatically bring those into that same service mesh. So right now, we're running these workloads on traditional virtual machines, and they're operating in a service mesh model, right? They're secured with MTLS between each other. We're able to apply or disallow communication via intentions. We can start to play with traffic splitting. And if we go into the Nginx server's job, you can see this interesting little template that I have placed here. And this is something that Consul has. This is an integration inside of Nomad using something called Consul template. And the work we're doing in the network infrastructure automation space is heavily based on this concept. I'm looking into Consul and I'm saying, hey, everything that's in the FE service, give me the address and the port, and write this as a file onto my Nginx server and drop that as this load balancer configuration file. So now every time this changes, Consul's going to reload this and handle the resolution of this application down. even though the nodes that are behind this are on a dynamic IP, doesn't matter because Consul is going to be looking for that IP and updating that Nginx file constantly. And this is the exact same thing that applies when Armand talked about how we're handling like things inside of an F5, right? From a load balancer pools perspective. And when we look at like how we handle firewalls and other load balancing platforms.
The nodes and the Docker containers and all that stuff can come and go at pretty much any moment. How is the console template being driven to, re-find out what the IP addresses are, provide that to Nginx?
So Consul is firing off a hook every time one of those change happens, and the agent that's running on the Nomad host is able to see that and actually like pipe that through Consul and through Nomad. So Nomad's job spec is watching, like the container was deployed, effectively has a watch on it that's saying, hey, look for changes. And whenever a service changes, reevaluate this expression and redeliver and then reload the actual job. If we look in
so Consul is running an app on every one of the ESX hosts that you have there?
So this isn't on the ESX host. These are 3 virtual machines that are effectively running Docker, and I'm deploying the workloads on this. So these are VMs living on an ESX host that are doing this. So there's 3 VMs, those Nomad host VMs.
So does each VM have a Consul plugin or?
Correct.
I got you.
Yep. So I have the Nomad binary running on them, and then also the Consul binary running as they're both running as a systemd service, right? So I have. Okay. How I do that in my environment is I build my images with Packer, and I deploy those images with Packer. So it's built into it, so I don't have to manage going in and installing it. And when I need to lifecycle that to a new version, I update my Packer manifest with the updated binaries and redeploy it.
And so would customers, if they wanted to utilize Consul and Nomad, need to run those binaries in every one of their VMs in their configuration? Is that?
So if you're going to do like the client nodes, so right here for like things that are going to run Nomad jobs, you need the Nomad binary on those to be able to talk to your Nomad server so that the scheduler understands how to place workloads. And then if you want to use, which you should, the Consul integration, yes, you need the Consul agent on there as well. They're lightweight binaries. They're very, very simple to configure, but you definitely do need the agent on both.
Okay, thanks.
No problem. So if we take a look at this app, we'll see my API is not working. Things are generally unhappy. And that's because of that default deny intention. If I go in here and I do a create on intentions, and I say, I want my front end service to be able to talk to my API service, and allow. If we go back in, we can see that's successfully connected now. I'm not going to go through just to save time. I'm not going to go through and do the database side. You can imagine when I go and enable database, it's going to pick up that as well. Now, this is where things get interesting because in this case, we've done our scheduling, right? Like this is a common problem that people have. How do we dynamically deliver workloads? And to the earlier discussion points, it's a little bit more palatable than deploying a Kubernetes cluster for every single person. However, we know Kubernetes is in the market. We know that this is an application platform for the future. So how do we bring that into this fold and start to do interesting things with that as well and have Consul be able to manage the network connectivity for workloads that live in Kubernetes as well? We're going to get very clicky between command line and interface now because I'm going to move between 4 different Kubernetes clusters, and we're going to join all of those to Consul. And I did this intentionally because one of the major things from a workflow standpoint that we focus on is making that experience really good. The experience of how you allow people to bring Kubernetes clusters into Consul and how we allow people to connect services that live across those clusters. So it was very intentional to show you guys me actually doing that live so you would see that it wasn't smoke and mirrors behind the scenes. So we're going to come back to Nomad in a little bit. There's more stuff that I want to show inside of Nomad around how we start to cycle out some of these jobs that have changed. So when we eventually bump up the version of our API service. So stand by as we move into our command line part of this adventure. So I've got a few different configuration files here. It looks a little daunting. I promise it's not as bad as it looks. A lot of these are the installation, the Helm chart YAMLs for deploying out out console. So if we go in and we look first at my vSphere environment, and this is the one that really resonates with me, being that most of you know my background. What's interesting to me about the vSphere use case and what we've done in WAN federation is that in a traditional federating environment between console, all of the nodes need to be able to talk between each other. So what that means in a traditional federation is that in a 3 server node cluster, those 3 nodes need to be able to talk to every other node in the environment. This is a massive amount of external firewall rules that probably isn't going to fly from anyone in network security. What we've done in Console 1.8 is made enhancements to our WAN federation capability, and now we send all of that traffic through a single port. So I can connect all of these environments together over one single externally exposed port. I talk about this concept a lot on Twitter with folks, and the idea that, like, I know many of you have labs at home. We could very easily federate our environments over one single NATed port, and that's how I do it in this. I have that console environment, the 3-node cluster. I have one IP exposed, and all of that traffic is going to come in via that IP NATed down into console. So this is the deployment YAML that is going to go alongside the Helm chart. So we're going to name our data center Humble Lab Kates. That's my lab's name. We've got our cert information, and then a couple of other configuration options within this. So we will go ahead and, yep.
Cody, just backing up a little bit when you were talking about just pumping through a NATed port. From what I remember reading about console, it generates its own internal CA to ensure HTTPS communication between its internal components.
That is an option, yes.
Yeah, when you expose that external NATed port, can you do that through Let's Encrypt to ensure that you're not putting a unencrypted port 80 out on the web?
Yeah, so you can set up different certificate authorities for console. So like a lot of people use Vault as an example. It's definitely an option. The internal CA is good, obviously, for testing purposes and for showing the functionality. But obviously, like in a production environment, do good things with certs. Use certs the right way.
Okay, I was just curious, as you were making me think about evolutions to my lab, I would like to be able to throw a Let's Encrypt cert on the exposed side of the system.
I mean, ultimately, the built-in CA is still a real CA. So from a security standpoint, there's pretty minimal concern, and you're not able to hit that mesh gateway yourself, right? Like there's no user traffic on that. That's purely service, like mesh gateway to mesh gateway traffic. And the mesh gateways, interestingly enough, don't decrypt the traffic. So the mesh gateways just pass the traffic along looking at the SNI header. So they just pass that traffic along. It's not until it reaches the endpoint that traffic is actually decrypted and viewed. So for you, like a Let's Encrypt cert, while it feels good to see the green check, you can't even actually see the green check because there's no interface for you to hit. You could probably use like OpenSSL and query it and pull it down, but there's nothing for you to see there. What we do last night when I set this up, I generated the certs for the VN-based console environment, and I took that CA cert and the key and used that to generate all the other certs, and we store that in this secret file here. All right, so this is the CA cert, this is the key, obviously it's encrypted, and then the different configuration items for how to actually have these environments connect. So the gossip encryption key encrypts console-to-console communication, and then this has my data center name and all of that. But these certs here are what are allowing the generation of certs in other environments. So when the Kubernetes cluster comes online, it looks at this cert and says, I have a CA cert. I'm going to generate certs based on this CA so that I have trust between these environments.
Okay, thank you.
No problem. So we're going to apply this.
While we're still on the cert rabbit hole here, does it self-sign cert that you have in there, does it expire and will it create new ones?
The cert does have an expiration. It's configurable for a length of time. I don't recall what my certs, like the one I generated last night, has from a default. Certs that are generated for, if you're using like the auto encrypt functionality of console, certs that are like client certs will regenerate those. You will have to regenerate periodically over time, unless you're using Vault. Like Vault will automatically do this for you as part of its PKI magic. But if you're doing this manually like I did, like I will have to cycle these certs eventually, yes. Automate everything. That's the lesson here. Automate everything. So I've created that secret in this environment. We're going to go ahead and do the Helm install. Actually, I'm going to make sure that I'm on the right. Okay, cool. I am on the right one. We're going to go ahead and do the Helm install, which is going to start the configuration. And at the same time, we're going to switch back in here, and we're going to go ahead and tail syslog. Oops, if I could spell right. Words are hard. In a few moments, that's going to pick up and start actually connecting over. Oops. And if we do a kube control get pods, we can see things are coming up. Now that crash loop backoff is expected. That's a gateway. So gateway can't come online until the server nodes are up and running. It's just taking a few for those to actually like come up. Right now it's creating persistent volume claims inside of like the vSphere provider for container storage. It's setting up all of that. So it takes a few to actually go through and run through that actual process. We can see things are starting to transition into a running state. So it's just taking a few to get there. It will, like I said, it will throw errors in the meantime. If we do a kube control get PVCs, we can see the PVCs are starting to run. And actually, I just realized I think that I used the wrong YAML file. Let's make sure. Nope, I did not. Okay, cool. Yep, okay. So that's running. It's taking a little while to start up that. So in the meantime, we'll switch over to the other clusters and start building those just to save on time. So I'll do the kubectx and we'll switch over to my Azure-based cluster. If we grab our files here, you can see my number 2 down here. Now the secret is a little bit different for public cloud because in my internal environment, I needed to tell it what my external IP address is. In public cloud, I get to just trust that public cloud knows how to handle that. So in this case, I am going to go ahead and just make sure I'm in the right environment. Awesome. And we'll do a kube control. Nothing to show in that secrets file. It's the same thing, just a little bit different configuration for this data center. All right, Azure AKS. Once that fires off, we will move forward onto the next portion. Go and check. Still waiting for that to come up. We refresh in here. Just waiting for those to come online. Server nodes are creating right now for the Azure environment. So while that continues on, we'll do our kubectx again. We'll switch over to our GKE environment. Once again, we'll apply our files for our secrets. Oh, I left the secrets already on there from earlier. So we see I already have the Federation secret there. Let's make sure I cleaned out everything. Cool, I did. So we'll go Helm install. So first, let's make sure we have the right systems here. All right, that's going to go off and run its thing now. We see there was a note here where one of them was added. So if we go back in, we do a refresh, I bet the AKS one is starting to come up. Yep. The Kubernetes one on vSphere is not looking, so we'll take a look at that in a moment and see if it's an easy fix. Probably something I didn't clean up from a previous run. So that's running. The Google one or the Google Cloud one is coming up now as well. And we're kind of hammering in this point at this point, but we're on our final cluster now, so we will finish it anyways. There we go. We'll grab our EKS file here. We switch back into console. I'm going to bet that we will see the other cluster coming up now. So there's our GKE. Interesting enough, if I go into AKS, you'll see I have that terminating gateway instance there. Now, I don't have anything configured against the terminating gateway at this point, but that's what Armand was talking about, how we can actually have this terminating gateway work against things like a managed Postgres instance. That's what I did in the 1.8 demo with Mitchell, was how to manage Postgres instance. And that allows me to apply service mesh policy against that are in console against things that are typically outside of the mesh that you can't run like a sidecar on. That lets us do things like traffic splitting against that external system, or have MTLS all the way up until that terminating gateway point. So it's a way of bringing external systems as close to being in the mesh as we can get them to be. Let's take a look here. So that's now running. If we do a Q control, get pods, we see the servers are up there. Let's go ahead and switch back to our vSphere environment one and see why that didn't work real quick. I can definitely say that it's not doing what it's supposed to at this point. So let's give a cube control logs. It appears I did something wrong from a search, or not a search perspective, from a persistent volume claim, because these are not coming up right now. Yeah. So it's waiting to create a volume in vSphere. So we'll let it do its thing. We don't need all of those clusters up. We switch back into console. Once again, we can see that we now have AKS, EKS, the GKE environment, and our virtual machine environment all in place. We'll go ahead and clean up this console deployment and see if we just fire it off again, if that will work for us. All right, so that's gone. We'll delete this other service account. Great. All right, so we're back to start on that. We'll do another install of this and just see if we get lucky on a second run. All right, so that's all there. Oops. Let's see if we can get our volume claims going now. There. If we hit this, we can see I have all of these environments are available now, and these truly are acting as a consistent control plane between all of these environments. And what we're going to do now is we're going to take some basic workloads and drop them onto the Kubernetes environment and see how we can start moving traffic between these environments. So we're going to apply this app, front-end app that I set up. And what we'll see is as we register these applications, these come online immediately. So if I go into the VM environment, these are all the ones that I had within Nomad, and we can see those registered via Nomad symbols there. But if I switch over to this Kubernetes one, we can see this is still coming up. The Ingress Gateway is still coming online. But we can see this front end service has registered, and that's that application that I actually built. So if we go in and we do a kube control get service, we can actually see, where is it? There it is. You can grab this IP address. And this app is going to look a little bit different. We can see our application in place here. Interestingly enough, though, if we go back and we look at that service definition for the application, this is what Consul understands is how to connect to this application, or how to connect this application together. If we look at the annotation section of our Kubernetes YAML, these are the things that Consul looks for to actually set up that communication. In a Nomad job, we have this in a job spec, and we say, hey, these are the upstreams that you want to talk to. In the Kubernetes file, we do this as an annotation, and we say, hey, the upstreams for this are the API service on port 5000, and we're going to point at our virtual machine environment. But we're going to do something very interesting with this, where we're going to apply a traffic splitting policy where we can take that resolution and pivot it into our AKS environment. So we haven't deployed our workload or our GKE environment, one or the other. We haven't deployed it yet, but we are actually going to do that. I'm also, just for grins, going to deploy another version of the API service co-located with this, with the front end service that's here. And this front end service, if we take a look at it, or this API service is actually going to be using the same thing from within Vault. So you can see, like, when we talk about that 1 + 1 = 3 experience, like, that's kind of what I'm harping on here. We're doing a lot of stuff around application connectivity and how we stitch applications to talk between environments. But at the same time, we're looking at how we stitch things in, like secure credentials and bring those in, how we handle dynamically scheduling workloads onto resources that might be virtual machine-based workloads instead of Kubernetes, right? Like, when you start to add these things together, you get that 1 + 1 = 3 like experience that Armand was talking about. So in this one, we have a little bit different stanza where we're injecting the Vault agent. We're pulling in secrets from our database. This is kind of a bad way to do this. I'm pulling static secrets out. We can do this dynamically and have it automatically create if we wanted to. It was a simple demo. So we're pulling this into the pod, and the pod is getting these secrets as part of its deployment. And again, if we go back into Consul now, we can see that API service is here as well. If we go into our intentions, and we tell our intentions, our intention is set up to allow communication. But if we go in and we look at our actual API service in the VM side, we see we're getting just a straight through communication. I mentioned before that we're going to take this and now we're going to split it up, and we're going to tell it how it can go between multiple environments. So I'm going to switch back into the command line. Clear out of this, clear this. And we're going to apply a couple of configuration files. And these configuration files are going to tell Consul how to handle traffic from within these services. So we're setting up things like service definitions where we're saying, hey, these are HTTP services. We're doing something called layer 7 routing here, or layer 7 traffic shaping, where we're telling the HTTP services how they can split traffic up. So we need to tell Consul that these aren't just TCP services. These are actual HTTP services that can take advantage of the layer 7 capability. So we're going to go Consul config write for each one of these. So this is setting it up for the GKE version of the service. This one's setting it up for the vSphere version of the service. Oops, little typo there. We're then going to set up, just so I can show you the next file, we're going to set up a service resolver. And what this does is tell console, hey, services live with the same name in other data centers, so let's bring those into the resolution. These would all be things you would store alongside your application artifacts. Like, we're doing this all manually here. That's not the typical experience that you would do in an enterprise environment. You would have this be part of a pipeline or part of some form of automation that was applying this via API to console. Like, you wouldn't necessarily, you might have an operator doing this, going hands on keyboard, but I tend to think that like the GitOps approach of having this drive via a pipeline is a much cleaner experience than just sitting in command line all day. All right, those are done. And then if we take a look at the splitter file, this splitter file is going to tell console to split the traffic for the API service between all three of these environments. So if we do a console config write for, and we go back in and look at console now, console looks very different because now console understands that these services live potentially everywhere or across multiple parts of our environment. And we're actually able to tell it that it can use traffic in either any of those environments. So this is still coming up. Still coming up for connectivity's sake. Just for grins, let's go in and just allow all traffic, just so we don't have to go back and forth on this. Take a few moments here. I'll pause. Any questions about what we've done so far?
So this sort of infrastructure as a service, I mean, a lot of this, service mesh and all that stuff, is it highly available? I mean, is there multiple entities running to support this? I mean, what happens if console goes down, for instance? Is there such a thing as console going down?
Yeah, so a lot of that's why, like, for example, we run 3 nodes in console, right? We have a gossip quorum between those individual nodes that allows communication between, or not, like, allows like a certain level of high availability. Because I'm running it on virtual machines, I can start to take advantage of some of the other like enterprise level features we have. Like we have resiliency zones that will automatically promote standby nodes to being like real parts of the server quorum. We have each one of these parts of the control plane, like if you'll notice, all of them deployed server workers. So if we go in and we look at the nodes here, each of these is a server, right? Like each of these have server nodes. So like if this link gets severed, that portion of the environment will still function. Like that portion of the environment is still there. Obviously, if like you lose connectivity between that, you have bigger problems for how traffic routes between those environments. But like the mesh gateways can be deployed in high availability, so you deploy multiple of them if you want to. There's a ton of high availability options here.
Okay, thanks.
And there's also now a hosted console, right? Console as a service?
Yeah, so there's 2 kind of versions of console as a service. Version 1 is what we released in partnership with Microsoft, the HashiCorp Consul service on Azure, where it's completely managed. And then also we have in private beta HCP, so HashiCorp Cloud Platform, that has its own managed console as well.
I know it's just been released, but are there any plans for that Azure version to be moved into their Gov Cloud?
We're definitely evaluating, right? Like the different like options in that space, like different ways that we would like want to deploy the service. It's definitely based on like, customer demand and evaluation of like actual needs. But I know that things like that are certainly on the table, especially for a product that focuses on security like console. So our original TFD service is connecting through to over the service mesh primitives. If we go back in and we take a look at our original file for the first one, oops. This is set for API going into that VM environment as well. So like this should be connecting over into that as an upstream, and we can check that by going into the actual VM, or the actual pod rather, I should say. Let's see. So just giving you a peek inside the environment, this is how Envoy is detecting where everything is at inside of the environment. So we can see that Envoy is able to see all of these, all of the different endpoints within my environment. So like it's able to see the API living inside of the Kubernetes environment and connect to it. It's successfully connecting to it there. So we see active connection successful. Right now, they had a couple of errors ahead of time. See if it's actually successfully connected at this point. So it's funny because it actually is connected. I don't know why the error message is showing there, because the database can only connect if the API is there. So I'm going to assume that this is more of just a flapping service scenario. There we go. So everything came online after a refresh. So last thing I'm going to do very quickly now is I'm going to show how we can fail back to Nomad and get us back to a good baseline, and then Nicole can take over. So we'll switch back into our Nomad environment. Oops, go into here. We'll find our Nomad job. We'll go ahead and bump this up. Oops, with our API version, we'll bump this up to, let's throw on, I think it's version 7, we'll just call it. And what's interesting about this is that Nomad has the ability to do canary deployments. So I've configured this one for a canary deployment, not a canary deployment, I'm sorry, for a staggered rollout. So what it'll do is it's going to only going to update 2 at a time, a max of 2 at a time, which is going to keep one version of the service on at all times. So while that's doing that, we will exit out of this pod. I can do a while here. This is going to start curling. So we're actually going to see where the API is failing, which one of the nodes it's failing at. Which takes a few for it to kick off. And to save on time for Nicole's demo, I'm going to switch in and I'm going to go ahead and switch all of our traffic back to the main API service instead of spanning across the clusters, which is what I was doing previously. So we'll go and do 100 there. We'll turn these both down to 0. One of those is failing because we never got to deploy it out into GKE just because of time constraints. All right, in a few moments that should pick up and start sending traffic back over to the other side. Actually, let's make sure that we're actually getting the right IP. Yeah, we're not getting the right IP from that. So we will go back in, we'll change this to 78. There we go. And now that we've failed all the traffic back, the splitting got a little messed up because we ran short on time, so I couldn't deploy it out to the different environments. That's actually why it was failing now that I think about it. We didn't get to deploy the service out across all 3 Kubernetes environments. But now that we've failed back into Nomad, we can see that it's actually successfully resolving against that Nomad, the Nomad-based API environment. So right now, how the traffic is flowing for this application, if we take a look back at console, this application's coming in through the vSphere-based Kubernetes environment, and it's actually sending it across Envoy into the Nomad-based API that lives inside of Nomad. So, and that is our messy demo this time.